Okay, we call this use special products formula. What do we mean by that? Sometimes in when you're finding products of binomials, they tend to occur frequently in algebra, and it is worthwhile for us to learn formulas for computing them. Very fast method. To develop rule to find the square of a sum or find the difference of, okay, so we will be working with that. So the difference of, so the square of a difference, the square of a sum. Okay, so those are the things. So we'll be working some examples. So let's say we have um, x plus y open close bracket squared. This can be in any letters, all right, or it can be combined terms inside, so long as you have something inside of bracket being squared. So the way you're going to multiply this out is as follows. I'm going to show you the step by step, and then I'm going to show you the shortcut. All right. So here we say now x plus y, because this is what this is saying. You're squaring the term, meaning multiply by itself twice. So if you notice that in xy squared, the base is x plus y, all right, and the exponent is 2. So we multiply the binomials. So we end up here now, and we say um, x times x, x squared, x times y, xy, y times x, xy, y times y plus y squared. This gives me now x squared plus 2xy plus y squared. Okay, so that's what we end up with. So first thing, you need to expand it out by saying that this is actually the base. All right, so this is the base raised to the power of 2. So let me write here some basic things. I'm going to write it out in x plus y squared, the base is x plus y. That's the base. And the exponent is 2. Right? Multiply then the binomials. Okay? And then combine the terms. X plus, no, xy plus xy, which gives me 2xy. We know that the terms of this result are related to the terms of the original expression. They're related. That is equal to the square of the first term. So notice here, this is related to this one here. How? Because the square of the first term, this is the first term, right? So let me write it here. First term, this is the second term. And let's see the fast method. It is related in such a way that the square of the first term, so we square the first term, x times x, x squared, plus twice the product of its terms. So plus twice the product of its terms. Okay, plus twice the product, I mean twice the product of its terms. So we put here xy, no, xy times, no, xy, and xy will give us 2xy plus square of its last term, square of the last term, which means y. Okay, so let me show you how this works. In shortcut, this is the way you're going to do this. Square this, x squared, that's x squared, 2 times x times y, that's the next way. So 2 times x, 2x times y, y squared, that gives me y squared. Done, you finish right there. So that's the same solution. All right, so all I did here is as follows, and I should write right now in words, or what I can do, I could just say it to you guys orally so that you guys can understand it. Or let me write down the steps what I did here then. um, X plus y squared is equal to the square of its first term, and what's the first term? X squared plus twice the product of both its terms, 2xy plus the square of its last terms, y squared. Okay, so let's go over it again. First term squared, then twice the product of its two terms, so x times y, xy times 2, because that's twice the product, okay? And then the last term being squared. Again, the terms of the results are related to the terms of the original expression. We find now, and this is known, let me write it here. When you see something like this, this is square of a sum. Square of a sum. Remember, square of a sum. Take note of it, square of a sum. Now let's go to the next example. Consider that we have now x minus y. We're going to do it the same method again. Expand, so this means x minus y times x minus y. Step, x times x, x squared. X times negative y, negative xy. Negative y times negative times positive x, negative xy. Negative y times negative y plus y squared, because negative times a negative will give it a positive. This gives us x squared minus 2xy plus y squared, and that's our solution. Now, because this type of problems tend to occur again, we're going to work it out the same method. All right, so let's work it out. We have x minus y squared. Okay, the first term squared, that's x squared, twice the product of the two terms, x times negative y, negative xy, but twice means put the 2 in front, so 2 times x, 2x times negative y, negative 2xy. Then the last term squared, negative y times negative y, that gives us a positive y squared. Okay, this is known as square of a difference, and it's good for us to learn this method, okay, because it tends to occur a lot in algebra. So the final special product of this is the product of two binomials. Now remember, we did square of a sum, square of a difference. Now we're going to go now slightly different, but it's the same concept. Let's see how that works. Consider that you have x minus y times, I'll put this positive first, x minus y. This one here, we multiply the two binomials, so we end up with x times x gives me x squared, x times negative y, negative xy, y times x plus xy, and positive y times negative y giving negative y squared. Notice the two terms, negative xy and positive xy, they will cancel with each other. Okay, that gives me now x squared minus y squared. Okay, now combine the two terms. When we combine these two terms, we get a 0. The product is the square of the first term. Notice here, once you see something like this, will resemble that. The first term, second term, except that their signs are different. The product is the square of the first term, so square the first term minus the square of the second term. That's it. So instead of going through this problem here, you can simply say, once you see a resemblance like this problem, you will simply say x squared minus the second term squared, and that's for that one there. So we have special products. Okay, so let me write this thing here for the special product. So this is known as product of a sum and a square. Product of a sum and a difference, okay, so let me write those three basic things here. We have here x plus y squared equals x squared plus 2xy plus y squared, and then we have x minus y squared give us x squared minus 2xy plus y squared, and then we have x minus y times x plus y give us x squared minus y squared. All right, so those are the three special products. This is, and this is, put here, square of a sum, square of a difference, and product of a sum and difference. Okay, so let's see if we can work some problems now. Let's do some exercises. So we're going to take some problems now and work them out. Okay, if I tell you find, means solve them. Okay, so example, we have a plus 9 squared. Okay, square the first term means a squared, twice the product of this of both terms, which means 2 times a times 9, and square the last term, 9 squared. So let me write what we just did here. Zoom in a little bit because I write some notes there. Square of the first term, square first term, okay, twice product of both terms, then square last terms. So we did that. So this is what happened here, and this is what happened here, and then we go one more step, and that gives us a squared plus 18a plus 81. We finish with that. Okay, let's go. So let's go over this again. The square the first term, which is a squared, then twice the product of the two terms, 8 times 9, which is here, times twice because the power is 3, I mean it's 2, and then you square the last term. Let's try the next example. Say 8a minus 5 squared. So we're going to square the first term. Square the first term, which means 8a open close bracket squared, and then put minus 2, twice the product of the two terms. Why do I take out the negative sign here? Because obviously when I multiply it out, it will still be ending negative, so take out the negative out of the way. All right, and then because you're going to be squaring the last term, which is negative 5, you're going to have 5 squared. This gives me now 8 times 8, 64a squared minus 10, 80 a plus 25, and we finish there. See how fast those steps are? Now go to our next example. Consider that you have 3y plus 4z times 3y minus 4z. Now remember, in the example for getting this, we only use a and b, or x and y, and so forth, but the concept is the same. The two terms here are the same, two terms here are the same, except that one of them have addition, next one have subtraction, or they have different signs. Okay, so we will be working that out. That's not a problem. So you work it out. First term squared, so because gonna be subtraction, the two middle terms will be canceling out. All right, so we end up now 3y squared minus 4z squared. This gives me 9y squared minus 16z squared. Okay, because remember, for this problem here, this is the same thing as this one here, product of sum and difference. This is what we did here also as an example. Notice that two middle terms would cancel out, so there's no need for you to work out this long step here. You could just square the first term minus the second term squared, and that's it for that one there. Okay. A common error when squaring a binomial is to forget the middle terms of the product. For example, um, uh, let me see and give an example. If I have x plus 2 squared, that is not equal to x squared plus 4. It doesn't equal to that. And x minus 2 squared is not equal to x squared minus 4. Okay, apply the special product formulas. We have now, if we were to multiply this out, we will have here x squared 2 times x, 2x times 2 plus 4x plus 4, and then here it would be x squared minus 4x plus 4. Notice, so this, be careful with these problems here, because this is the ones where people will tend to make mistakes. Okay,